Okay, we are recording. Okay, can I do number 7 and 8 from the quiz? Yes, I can. Okay, that's from the back side. All right, so number 7 from the quiz is asking us to write the equation of a circle. So quiz number 7. Here's what they tell us about the circle. The center is 2, 6. Put C for center. And then it says it goes through the point 8, 3. So that point 8, 3 is a point on my circle, and 2, 6 is the center. All right, so here is what you know so far about your equation of your circle. It's x minus 2, the quantity squared, plus y minus 6, the quantity squared. Now this is supposed to equal r squared, okay, but we don't know what the radius is. So I'm going to show you two different ways that you can go about doing this. One is to find the distance between the center and this other point that they gave us. Okay, so I'll start off by doing that. That distance is going to be the radius. So I'm going to write r equals. So of course we know our distance formula like crazy from that second to last section of our chapter 9. And so I'm going to go difference of the x's. Let me kind of write out the setup of this. Difference of the x's squared plus difference of the y's squared, and then all of that in a big square root. Okay, so I'm going to go 8 minus 2 for the difference of the x's and 3 minus 6 for the difference of the y's. So 8 minus 2 is 6, squared is 36, plus 3 minus 6 is negative 3, but I square it, I get positive 9. And so square root of all that is the square root of 45. So that is the radius of my circle, is the square root of 45. So since I want r squared, my equation is going to become x minus 2, the quantity squared, plus y minus 6, the quantity squared, equals, and then I'm going to square my radius, which is the square root of 45. And so the equation has 45 on the right side of the equal sign. Okay. Now the square root of 45 simplifies to 3 rad 5, but I don't need to do that because I'm just trying to write my equation. So I just need to square the square root of 45, and that's actually easier to square when it's not simplified. Okay, then let me go to the next page, and I'm going to show you a second way you can go about doing this. Let me write the information they gave us again. So they told us the center was 2, 6, and they told us the circle contains the point 8, 3. Okay, so I'm going to write the left side of my equal sign again. So x minus 2, the quantity squared, plus y minus 6, the quantity squared, equals r squared. And this time, I'm just going to take this point that they gave me, 8, 3, and I'm going to plug it into my equation. So the 8, I'm going to plug in for the x, and the 3, I'm going to plug in for the y. And that will tell me what r squared equals. So when I plug in an 8 right here for x, 8 instead of the x, I get 8 minus 2, which is 6, and squared is 36. Plus, when I plug in my 3, you'll notice that this is exactly what the distance formula was, right? 3 minus 6 is negative 3. Square it, I get 9. And that sum equals r squared. So 45 equals r squared. And I don't even need to take the square root and solve for r, because look at my equation is supposed to equal r squared. So I just cross out that r squared and I write 45, and there's my equation. Okay. All right. So two different ways you can go about doing that. All right. Number 8 from the quiz is certainly the problem that you know the least about, because we never saw that in our homework until you did your review. All right, so I personally think for number 8, you absolutely should have a picture drawn. So they said, find the equation of the ellipse. So they tell us it's an ellipse. And then they say, with major axis length 12, we'll talk about that. And then it says, and the foci are at 1, 7. So there's 1, 1, 2, 3, 4, 5, 6, 7. Put a point right there. Okay, so that's one of my focus points. And 1, negative 3. So 1, 2, 3. Let me label the negative 3. So if this is one of my focus points up here and the second focus point down there, isn't my center halfway in between? So if you recall, the midpoint is the average of the endpoints. So I'm going to take that 7 and average it with -3. So that means add them and divide by 2. So 7 plus a -3 is 4, and then divide by 2, I get 2. And so the center of my ellipse is this 1, comma 2. All right, so actually just by knowing what the center is, I can start writing my equation. So I have x minus 1, the quantity squared. That's going to be divided by the x radius squared. Then I have a plus sign. Y minus 2, the quantity squared. That's going to be over the y radius squared. And then my equation is going to equal 1. So all I need to do is figure out what my x radius and y radius are. Okay, so there's one piece of information I haven't used yet. It said the length of the major axis is 12. And so the major axis, I know, is the long part of my ellipse. And if my ellipse were opening sideways like this, horizontally, my major axis would be horizontal. But if my ellipse is vertical like this, then my major axis is vertical. Well, since the foci lie on the major axis for an ellipse, they told me where these foci are, and they're definitely up and down. So I know my ellipse is opening vertically. Okay, but if the major axis has a length of 12, let me go like this on my little example up here, that whole length is 12. Well, wherever my center is, that means what's above it is 6 and what's below it is 6. Well, guess what? That's my y radius. And so underneath this quantity for the y's, I know I'm going to have 36 because my major axis is the axis that my foci lie on, and from the center to the top is 6, and from the center to the bottom is 6 for a total length of 12. Okay, so since this distance from 7 to 2 is 5, that is my C, okay, that we usually have to go and calculate. Well, they told me what it was now that I have found my center because they told me where those points were. So if that distance is 5 and my y radius is 6, let me continue and put an 8 right here, put a point up there, and then go down one more and put a point right there. And so I'm just going to kind of arbitrarily draw my ellipse without knowing what my x radius is yet. Okay. All right. So there's my ellipse, and I don't know what my x radius is. So I'm looking for this right here, this distance from the center going to the right or to the left. So this is where your equation for finding the foci normally is going to tell us what the x radius is. So I know for an ellipse, the equation for c squared is c squared equals a squared minus b squared. Remember, it has the opposite sign as our equation. The equation for an ellipse has a plus sign in the middle, so the equation for c squared has a minus sign in the middle. Hey, Bear, is that you? Boo Bear, come here. Come here. Come say hi to my students. Come here. Bear, Bear, come here. It's playing with Snickerdoodle. Okay, so here's what I know. I know c equals 5, so c squared is 25. Then I know that when I'm solving for c normally, here I don't need to solve for c, that I always put the bigger number for a squared because when I'm subtracting, I want the larger number to be first so that I get a positive number. So the larger number is the y radius. And so we already know that that's 6, and then squared will be 36. And then minus my b squared is going to be the half of my minor axis. Well, I don't know what that is. That's exactly what I want to solve for. Okay, so I'm going to do 2 steps, and they're probably not the 2 steps you guys would do to solve for b. I think most of you would subtract 36 from both sides. I'm going to add b squared to both sides. So that comes over here. That allows me to subtract 25, and I get positive 11. Okay, so if I want to solve for b, I would take the square root of both sides, and b would equal plus or minus the square root of 11, but this is a length, so I'm just going to put the positive, and that is my x radius. So if that distance is the square root of 11, underneath the quantity, I want to put the square of that, and so it's 11. And so there's my equation. Okay, so it was all about, I think it's all about first drawing your picture, understanding that if once you find your center, let me put that in red, once you find your center, then knowing where the foci are, tell you what your C value is, that's called the focal radius. Then because they told me that the major axis length was 12, that told me that my y radius was half of that, so 6. And so that means that in this equation, c squared equals a squared minus b squared, I knew my c squared and I knew my a squared. I just had to solve for my b squared, or rather my b, and then square it. So yes, b squared. Okay, and there's my equation. Alrighty, let's see. Patrick is asking for number 4. Yes, I think that even though there's a lot of work on 1, 2, and 3 for completing the square, for an ellipse, completing the square again for a hyperbola, completing the square again for a circle, there's a lot of work for 1, 2, and 3. Then you get to a parabola, and I feel like many of you are not quite as competent at that. So let's look at this number 4. All right, they gave us 3y squared, which is a little unusual. Usually they start with the x squared. Well, and actually, usually they put the x before the y, so that's interesting. The reason they did not start with x squared is because there isn't one. And so I look at my variables and I go, there's only a y squared, not an x squared. That automatically means that this is a parabola. And so since I do have a y squared and a linear y, what I want to get all alone is the x from this term right here. Okay, so I'm going to leave my 3y squared and my plus 12y and my plus 7 on the left side of the equal sign, and then I'm going to add 5x. And then my goal is to get x all alone, so I'm going to divide every term by 5. And I know you don't love that there are so many fractions in this equation, but that's the way it is. So that 3/5, that's my a. So this is ay squared plus by, my b is 12/5 times y, and then my c is 7/5, and that equals x. So the fact that the x is all alone and the one that is not squared, that tells me this is opening in the x direction horizontally, either left or right. So next I look at my a, which is right here, positive 3/5, and that tells me that this parabola is opening to the right. Okay, now to find the vertex, I have to have memorized negative b over 2a. So the opposite of b is negative 12/5. 2 times a is 6/5. So now let me say this, dividing by 6/5 is the same as multiplying by 5 over 6. And when I multiply that negative 12/5 and that positive 5/6, the 5s are going to cancel. I get negative 12 over 6, and that equals negative 2. Now that's the y coordinate of my vertex, because if you're wondering, how did she know it was the y coordinate, not the x coordinate? It's because when you go to find the missing coordinate, look at your equation. You're going to go and plug that in for y. Okay, so my negative 2 squared is 4 times the 3/5 gives me, I'm going to jot it down right here, 12/5. Then I plug in my negative 2 for the y in the second term, and I get minus 24/5, and then plus 7/5. And so I get negative 5/5, which equals negative 1. And there is my vertex, negative 1, negative 2. All right, I'm going to go to the next page to graph this. So negative 1, negative 2 is my vertex. As soon as I plot that vertex, I'm going to draw my axis of symmetry. And the reason I know it's horizontal is because we've already talked about why it is, or the fact that it is opening to the right. Okay, I'm going to go back a page and circle something. When your equation is in standard form, this c value right here is an intercept. I'm not completely convinced you guys know whether it's an x or a y intercept, but that is very important. So if I plugged in a 0 for y, do you agree this term would go away? This term would go away, and wouldn't I get x equals 7/5? So let's go back to the graph. x is equal to 7/5 on the x-axis, and that is an x-intercept. So 1 2/5. And that point, by the way, is 2 above my axis of symmetry. So I'm just going to go 2 below, and I get a 2 for 1 special. And now I've got 3 points. Now, some of your teachers may be okay with you showing your graph with 3 points, but any of my students know I want a minimum of 5 points. So I'm going to go back to my equation page. And in this equation, I either want to plug in a y equals 1 or a y equals 2. Okay, let's go ahead and try y equals 1. I'm going to do this in green so it stands out. So when my y is 1, let's see what we get. I plug in a y equals 1, square it. That's going to give me 3/5, and then plus 12/5 plus 7/5, and I get 22/5. And so I'm going to write 4 and 2/5, comma 1. Let's go back to the graph. So there's 2, 3, 4, 5. So when y is 1, I've got 4 and 2/5. That is 3 points or 3 units above my axis of symmetry. So I'm going to put the same x value 3 points below. And I'm going to try to do a nice smooth curve, but this is kind of hard to draw on. And there's my graph of my parabola opening to the right. By the way, I want to use one of my group's wrong answers just to kind of make a point. Parabolas look like parabolas look like. You guys have seen parabolas for a long time, okay? Sometimes they're wider, sometimes they're more narrow, but they never look weird. And so I just want to show you what somebody did. I'll show it on a different graph so I don't mess this one up. Okay, they got their vertex correct. They plotted it. I don't remember if they showed their axis of symmetry, but of course they should have. Okay, and then let me go back a page. This circled in red 7/5, 1 and 2/5. They knew it was an intercept, but they thought it was a y-intercept. So they went like this, 1 and 2/5 up here, and then that's 1, 2, 3 and 2/5 above. So then 1, 2, 3. Okay, so I didn't give myself much room. That's all right. So then they put another y-intercept there. Okay, and then I think they plugged in 2 for y. Let's go ahead and do that. I didn't plug that one in earlier for my graph. Let me do this in red. So they plugged in, let's say 2 for y. So when I square 2, I get 4. That's going to give me 12/5. Then I plug in 2, I get plus 24/5, and then plus the 7/5. Let's see, that's going to be 36, 40, 43/5. All right, so this is 8 and 3/5. All right, let's go to the next page, and I want to make my point. When I go out to 8 and a little bit, let's go 1, 2, 3, 4, 5, 6, 7, 8. So they got this point, and then I'm kind of running out of room, so I'm going to just put it over there. But here's what their graph looked like. I'm going to do this in red so it really stands out. They went from their vertex up here, and then they went like this. And then they went from their vertex down here, and then they went like this. Does that look like any parabola you guys have ever seen? Parabolas don't do that, okay? So obviously it's because they thought their C value was a y-intercept when it was truly an x-intercept. So that's why that point is so important, okay? But I say this is complete nonsense, and they should have known it because it doesn't look like a parabola. It doesn't go all flat like that at the bottom and then go off. Anyway, just wanted to use that as an example. Okay, so parabolas don't look weird. If they do, you're probably wrong. Okay, Patrick, I hope that was helpful. Okay, Kenji, can I do number 7 from the homework? Kenji, you're going to have to be more specific than that. I need to know what page number. I'm not sure what number 7 you're talking about. Okay, so please specify. Okay, Phoebe, can I do the last question from today's quiz? I think I've already done it. Yes, I have. So you'll have to go back and watch. You must not have been on when I was doing that. Okay, Sneha, can I do T5 from the review homework? Yes. And Kenji, if you were asking for T7, just let me know. All right, chapter 9, T5. Okay, T5 says in the directions, transform the equation by completing the square, then sketch the graph. All right, let me label that this is page 511, number T5. Okay, so here's the equation they gave. X equals 0.2 y squared minus 2y minus 3. All right, and this is considered standard form for a parabola, and I'm personally just going to leave it like this. Now, you could change it to vertex form. I think it's just easier to let's just calculate the vertex. So I'm going to do negative b over 2a. That is something you need to have memorized. So the opposite of b is 2. 2 times a is 0.4. So my 2 divided by 0.4 gives me 5. And if I'm not sure if that's my x or my y coordinate of my vertex, I just look at my equation that they gave me. And do you agree? You're going to go and plug it in for y and figure out what x is. Okay. All right. So 5 squared, of course, gives me 25, but times 0.2 is 5. And then I have minus 10 minus 3, and that gives me negative 8. So my x is negative 8, while my y is 5. That is my vertex. And since the x is all alone, the one that's not squared, I know this is going to open either left or right in the x direction. And since my a is positive, it's going to be to the right. Okay, so let me put my xy axis like this. Let's go negative 1, 2, 3, 4, 5, 6, 7, 8. I'm going to label that negative 8. 1, 2, 3, 4, 5. Let's label that 5. Since we know it's opening to the right, my axis of symmetry will be horizontal. That's supposed to be going through the 5. And then I'm going to look at my equation in standard form. This negative 3 is an intercept. Stop and think. If I plugged in 0 for y, wouldn't both of those terms that I just underlined become 0? And I would get x equals negative 3. That absolutely is an x-intercept, not a y-intercept. Okay, now this is pretty far above the x-axis, but since I have that x-intercept 5 units below, I'm going to go 1, 2, 3, 4, 5, 5 units above the axis, and I get another point of symmetry. Okay, so I've got 3 points right now. I personally would prefer 5, not prefer. I want my students to have 5. So I think I'm just going to plug in negative 1 for y. All right, and I'm going to use a calculator. So with a negative 1, when I square negative 1, it becomes positive 1, so I just get 0.2. Then a negative 1 times a negative 2 is plus 2, and then minus 3, and I get negative 0.8. You know what? I don't think I'm going to plot that. I'm going to plug in negative 2. So negative 2 squared is 4 times 0.2 plus, I'm plugging in negative 2, so plus 4 minus 3, and I get 1.8. All right, that's a little bit better. All right, so 1.8 is about right here, and that is 7 units below, so I'm going to go 7 units above, and I get a point of symmetry. Okay, so now I have 5 points, and I'm able to do a fairly accurate graph. Okay, and this should be a little bit smoother or rounder, so to speak. It's kind of hard to draw on this. So, okay, so there's my parabola. I know that looks a little bit weird. That's because I didn't draw it well. Okay, but the points make sense. All right, there you go. That's T5. Okay, Dylan 5 and 6 from the quiz. Let's see if I've done those yet. No, I have not. Okay. So number 5 is one of those distance problems. Okay, and the first thing you should do is draw a picture. I'm a little astounded that some people are trying to write their equation without drawing the picture. I just think that's a really big mistake. So it says for each point in a set of points, its distance from the point 2, 3. So I'm going to start off by plotting that point 2, 3, and I'm going to label it in a different color, 2, 3. All right. So its distance from the point 2, 3 is 2 times its distance from the line x equals 6. So 3, 4, 5, 6. All right, so here's my line. Sorry, that's not so straight. X equals 6. Okay, so I'm going to read it again, and I want you to think to yourself, is my sample point, and this is a point that represents every point, either on an ellipse, a hyperbola, a circle, or a parabola. We don't know what it is yet. We're going to determine that. So I want you to tell me what my sample point is further away from. Is it further away from the point 2, 3, or is it further away from the line x equals 6? So I'm going to say it again, and I'm really going to exaggerate the words 2 times. So for each point that I'm trying to write down, this p x comma y, its distance from the point 2, 3 is 2 times its distance from the line x equals 6. Do you agree it is further away from the point than it is from the line? So I'm going to put my point P right here. Okay, and that's not a magical place necessarily, but I think it makes sense. Okay, I'm calling it point P, x comma y, because it stands for every point. And if I connect, let me connect in green. If I connect those 2 points, I think that looks like it might be twice as long as this distance, okay? And it doesn't have to be exact, but I do think you should be able to tell which one is the long one and which one is the short one, line segment. I'm going to call this L for long and this S for short, okay? And then we're going to be doing the distance formula, and so I have to have points. Well, the 2, 3 and the x, y, that gives me the endpoints of my long segment. For my short segment, I have the point xy, but then right here where my green line segment touches that line, I need to label that point. Well, I know the x is 6 because it's on the line x equals 6, and then my y, I'm going to call it the same y as my point P because that's on a horizontal line segment. Okay, so now I really think this is a very important part right here, is I'm going to write an equation that involves the letter L, the letter S, and the number 2. So do you agree with this? The long line segment equals or is 2 times the short line segment. Okay, and if you want to, you can plug in numbers to see if it makes sense. Well, if my short line segment has a length of 3, do you agree 2 times 3 would mean that my long line segment would have a length of 6? And then ask yourself, does it make sense that the short one is 3 and the long one is 6? Yes, that makes sense. The biggest mistake on these problems is students will take that 2 and they'll put it on the side of the L of the long one. And that's completely wrong. That would give you 2 times 6 equals 3. Well, it doesn't. 2 times 6 is 12, not 3. So that doesn't make sense. Okay, then I'm going to use this equation that I just wrote, L equals 2 times S, and that's going to tell me how to do my distance formula and find my equation. All right, so the distance formula for L, I'm looking at the point 2, 3 and the point xy, and I'm going to do the difference of my x's, so x minus 2, the quantity squared, plus difference of my y's, y minus 3, the quantity squared. So there's my L, equals 2, and then times big square root, and now I'm going to do the distance of my short line segment, and so the difference of the x's is going to be x minus 6 squared, plus the difference of my y's is y minus y squared. Well, y minus y is 0, so I'm just going to cross that out right now. Okay, my next step is to get rid of my radicals by squaring both sides. And on this right side, of course, I have to square that too. Okay, I'll do that when I get to it. On the left side of the equal sign, the square cancels with the square root, and I get the stuff inside, and I'm going to go ahead and start squaring those binomials. So I get x squared minus 4x plus 4 plus y squared minus 6y plus 9 equals, for the quantity, you have to put this in parentheses. Okay, I squared my 2 and got 4, and then you have to put parentheses. And when I square my square root, the square will cancel the square root. I get the stuff inside, which is just x squared minus 12x plus 36. And remember, the y minus y was just 0, so that's gone. Okay, next, I need to distribute this 4. I'm a little worried about that because a lot of students make mistakes with the distributive property for some reason. So 4x squared minus 48x plus 24, that's going to be 144. Okay, on this left side, I'm going to rewrite this again. X squared minus 4x plus 4 plus y squared minus 6y plus 9. All right, so the order we want to go in for our final equation is to have the x squares first, then the y squares, then the linear x's, then the linear y's, then the constant term, and then set it equal to 0. So the first thing I'm going to look at or look for is x squared. Well, here's an x squared and here's an x squared. Since the x squared is on the left side of the equal sign and the 4x squared is on the right-hand side, that's going to tell me to bring everything over to the right side of the equal sign. I want the left side to equal 0. So one term at a time, I'm going to take care of this. I'm going to subtract x squared. That gives me 3x squared. And then I suggest you cross those out so you know you're done with that term. Next, I want the y squared. Well, there is only one y squared right here, so I'm going to subtract it. So I get minus y squared, and then I'm going to cross that out. Okay, I'm going to continue in just a moment, but right now, with both of those first two terms right there, I already know this is a hyperbola because my x and y are both squared, but my coefficients have opposite signs, and so that's a hyperbola. Okay, now let's continue. I want my x's next, so I'm going to add 4x to the right-hand side. Whoops. And so I get minus 44x when I add 4x to both sides. So that's gone. That's gone. Okay, next I want my y's, and so I'm going to take this only y, this negative 6y, and add it. So I get plus 6y. That one's gone. And now I'm going to look at what's left. I have a plus 4 and a plus 9, and on this side a plus 144. So that 13 on the left side, I need to subtract 13 from both sides, and so I get plus 131. So this is my equation, and we already said that it was a hyperbola. Okay, there you go. Okay, Dylan, that was number 5. Here is quiz question number 6. All right. 6 asked you to identify the conic sections. So let me write the equations down. It's x squared minus y squared equals negative 7. Oops. And then and because of that minus sign right there, and both of the variables are squared, I know this is a hyperbola. I'm going to abbreviate it. Okay, my second equation says 2x squared plus 3y squared equals 66. Well, the x and the y are both squared. Their coefficients are both positive, but they are not equal. So this is an ellipse. By the way, ellipse has 2 L's. Quite a few of you are misspelling that. Okay, so I can get rid of either the x squares or the y squares. However, because the coefficients of y squared, one of them has a negative coefficient, the other one has a positive. That's the one I'm going to choose. So I'm going to multiply this first equation through by 3. Let's go ahead and do that and bring it down here. So I get 3x squared minus 3y squared equals negative 21. And now I'm ready to add those two equations. That gives me 5x squared. My y squares cancel completely, and I get equals 45. Next, I divide by 5. Then I take the square root of both sides, but don't forget plus or minus. So I get x equals plus or minus 3. All right, next I'm going to go back and plug that in. I think I'm going to plug it into the first equation. So whether I plug in the positive 3 or the negative 3, when I square it, I get 9 minus y squared equals negative 7. I'm going to add y squared to bring it to the right side of the equal sign. Then I'm going to add 7 to both sides, and I get 16. And so when I take the square root of both sides, I get y equals plus or minus 4. Please don't leave your answers like that. You need to write it out into points because I'm not sure if you know what that means. So I have a positive 3 for x. I'm going to write it twice because with that positive 3 for x, I either get positive 4 or negative 4 for y. Then my negative 3 for x, again, I get positive 4 and negative 4. Okay, so that is the solution set. By the way, quite a few people were asking on the test, what do they mean by solve? Well, or what to put on the answer column line for B. Well, when they ask you to solve, it's a system of equations means what are the points of intersection? So that boxed set of 4 points, that's exactly what they mean by solve. Find the solution set. All right, so that's what you put on your answer column. Then part C asked you to graph both of those. All right, so let me take the x squared minus y squared equals negative 7. I know that's a hyperbola, and so I want my equation to equal negative 1. So I'm going to divide all 3 terms by negative 7. Since the y squared is now going to become positive, I'm going to write it first, y squared over 7 minus x squared over 7 equals 1. You see how my minus sign now is in the middle? And there's my equation. All right, so I want to know what my x and y radius will equal. So I'm just going to put that r squared is approximately, and I said that wrong, not r squared, r sub y is approximately, and I'm going to take my calculator and plug in the square root of 7. Let's see, that's 2.6 approximately, and so this is also 2.6. Okay, so here's my graph. All right, my center is at the origin, 0, 0. My x radius for my hyperbola is 2.6, so about right there and there. And then my y radius is also 2.6. Okay, that is going to give me my fundamental rectangle. So I'm making this dashed square. Okay, and then my asymptotes are going to be the diagonals of the square extended. And by the way, that's typically going to be a rectangle, but because my x and y radius were the same, radii were the same, that's why it's a square instead. Okay, you have to know which way it's going to open. So when your equation is all set up like I have here in the box, and your minus sign is in the middle, the leading term, the positive term, the first term when your minus sign is in the middle, that tells you which way your hyperbola branches are going to open. The y is in the leading term, and so that means it's going to open up and down. Now these 4 points helped me draw my rectangle, or in this case a square, but this point right here, now that I know that it's opening up and down, and this point right here, those are very important points. They become vertices of your hyperbola. They are actually the only 2 points that we know exactly the values of the coordinates. All the points that I'm drawing right now, that's supposed to be a smooth curve for my hyperbola branch. Whoops, I'm definitely going to delete that. I need to stay inside the branches of my asymptotes. All right, so that is my hyperbola. Okay, next, the second equation was 2x squared plus 3y squared equals 66. Well, I know that's going to be an ellipse, and so I want the equation of my ellipse to equal 1. So I'm going to divide everything through by 66. And even though the numbers aren't going to be great, at least it simplifies. So I have x squared over 33 plus y squared over 22 equals 1. And again, the fact that they're not nice, neat, perfect squares, no big deal. I'm just going to use my calculator. So I go square root of 33, and that's going to give me my x radius. And I have it right here. It's approximately 5.7. And my y radius is the square root of 22. That's exact, but the approximation is approximately 4.7. Okay, so this is for my ellipse, centered at the origin. I'm going to go left and right 5.7. By the way, I haven't done this yet, but I strongly suggest doing it. Let me go back to the previous page. Remember, I have my 4 points here that I think are my solution set, plus or minus 3 together with plus or minus 4. I would suggest you plot those on your graph. I should have done it before I graphed my hyperbola. Okay, so 3 for x, 4 for y, and look at that, a point right on my hyperbola branch. And then negative 3, positive 4 right there, positive 3, negative 4 right there, and negative 3, negative 4 right there. Okay, so there are my 4 points, and now I'm ready to graph my ellipse. And so, in black. All right, so from the center, I'm going to go out left and right 5.7. So 1, 2, 3, 4, 5.7. Okay, that's 3, 4, 5, 6, 7. Oops, I went too far. All right, so 1, 2, 3, 4, 5.7 is what I meant to do. Okay, and then in the y direction, up and down 4.7, that's 1, 2, 3, 4.7 would be about right there. And then 1, 2, 3, 4.7 about right there. All right, so not only do I have my points for my ellipse to be able to draw this, but I also have those green points that I know are supposed to be my points of intersection. So that certainly helps in the graphing of this. Okay, and I'm just going to circle my 4 answers. My graph confirms that we did the algebra correctly. And there you go. Okay, Dylan, there you go. Kenji, the question asks, write the equation of the parabola having vertex 0, 0 and directrix y equals 2. All right, so here's the deal. Our book does not talk about a focus point for a parabola or a directrix. I have a feeling, Kenji, you must have Mrs. Brucolari. So I don't know if that's a worksheet or what, but the rest of the classes did not do anything with a directrix. Okay, and so I would suggest that you ask her, okay, because our book does not go into directrix or a focus point for a parabola. And so I don't want to confuse everybody doing something that's not from the book. Okay, all right, can I do number 3 in section 9-8 from the textbook? Yes, let's see how we're doing on time. We have 15 minutes left. Okay, 9-8. And number 3. Okay, so this is another problem like what I just did, except for it does have something that's very interesting in it, and I think is good for you guys to see. Page 503, number 3. Okay, here are the 2 equations. X squared plus y squared equals 25. It doesn't get a whole lot easier than that, right? Obviously a circle with radius 5. Okay, so that's a circle. And then I have, I'll write it just the way they did, y minus x squared equals negative 5. Well, the x is squared, but the y is not. This is a parabola. Okay, however, I need to get rid of one of my variables. I don't have them lined up right now, but let's circle in green. I've got a y squared term in the top equation, the first equation, and in the bottom equation, I have a linear y. I would like to keep those in my sum when I go to add these and get rid of the x squares. First of all, I wouldn't be able to get rid of the y squared because there's nothing to line up with it. Okay, but that linear y right here tells me, since I have that linear y, I need to keep the y squared also. So that tells me I need to get rid of the x squares. Okay, so here's how I'm going to rewrite this. The x squared plus y squared, I'm going to leave that alone and leave some room before I write equals 25. And now look at the second equation. I'm going to rewrite it. I'm going to write negative x squared first, and then where that blank was, I'm going to put plus y equals negative 5. So see how I'm lining up my x squares, I'm lining up my equal signs, I'm lining up my constant terms, but I'm making sure that the linear y does not line up with the quadratic y. Okay, these are ready to be added. I don't even have to multiply anything through by anything because my x squares are ready to cancel right now. So they do cancel. And so I get y squared plus y equals 20. So now to solve that quadratic equation, I'm going to subtract 20 from both sides. This happens to be factorable. And so I get plus 5 minus 4. And so y equals negative, excuse me, I just wrote x equals. I said it correctly and I wrote it wrong. Okay, that's y, oops, 4. Y equals negative 5 and positive 4. Excuse me. Okay, now I'm going to go back and plug that in. I think I'll plug it into this equation right here, the second one. So if my y is negative 5 minus x squared equals negative 5, if I add x squared to bring it to that side and then add 5 on both sides, I get 0. And so x equals 0. So I get the point 0, negative 5. That's 1 point. Then I'm going to plug in 4 for y. So I'm going to get 4 minus x squared equals negative 5. Again, I'm going to add x squared to bring it over to the right side. I'm going to add 5. That gives me 9. And here I get x equals plus or minus 3. Don't forget the plus or minus. Okay, so I get positive 3 for x with a 4 for y and negative 3 for x with a 4 for y. So these are my 3 points of intersection. And the next task is to graph and see if those 3 points make sense. Okay, so I'm going to start with x squared plus y squared equals 25. So we already set a circle with radius 5. Center is at the origin. 1, 2, 3, 4, 5. Put a point. 1, 2, 3, 4, 5. Put a point. 1, 2, 3, 4, 5. Put a point. 1, 2, 3, 4, 5, put a point. And before I draw my circle, I'm going to go back and look at my solutions. 0, negative 5. Let's plot that point, and I'm going to do it in red. 0, negative 5 is this point right here. Then go back to the previous page. 3, 4, and negative 3, 4. So positive 3, positive 4 is right about here. And negative 3, positive 4 is about right there. So when I go to draw my circle, now not only do I have my 4 points showing the radius of 5, but I also have these red dots that are supposed to be my points of intersection. So of course that means my circle has to go through them if they really are going to be the points of intersection. Okay, and that looks, reasonable right now. Okay, my second equation, let me go back and look that up. It is y minus x squared equals negative 5. I want to get that y all alone. Y equals positive x squared minus 5. So now there's my equation. I know that is a parabola that opens up because the y is all alone. So that tells me it's going to open vertically, up or down. And then because my a, the positive 1 in front of the x squared is positive, I know it's going to open up. Okay, so I'm going to do negative b over 2a like I always do to find my vertex, but my b is 0. And so I get 0. That happens to be the x coordinate of my vertex. When I go to plug it in, I plug it in for x, and I get y equals negative 5. So 0, -5 is the vertex of my parabola. Okay, and I have 3 points right now, actually, the 3 red ones that are on my graph. I would like to have 2 more points on my parabola. So I'm going to plug in x equals 2. So if x is 2, let's plug that in. I get 2 squared is 4. 4 minus 5 is -1. So 2, -1 gives me a point on my parabola. And since I know this is a vertical parabola opening up, then I can go 2 units to the left of my axis of symmetry, which is my y-axis. That goes through the vertex. And so now I'm ready to graph a pretty accurate parabola, and you can see that it makes sense, that it's going to truly intersect with those 3 red points. And that's the graph that confirms that these 3 points are my points of intersection. Okay, very good. Okay, let's see. That was Josh's question. Okay, if anybody has one last question, we have a few more minutes, but I am doing back-to-back GBLs for Advanced Math Trig in just a few minutes. So if you have one last question, ask it quickly. Otherwise, we will stop. Anyone, anyone? All right, I hope that was helpful. Oh, Dylan's typing. Let's see. Is it a question or is it a thank you? Dylan, will we be able to watch this after real quick? Yes, as soon as I get off of this, I will be posting it on Adobe Connect. The YouTube version, though, will not be up until tomorrow, but you can watch it on Adobe Connect probably in about 5 minutes. Okay. All right. I hope that was helpful, and good luck on your test Friday, and good luck on your finals, everybody. All right. Good night.